We're going to get into now more specifics of folds, especially how their limbs and how their axis can change over space. Let's talk about the limbs of the fold first. So this is an anticline here followed by a syncline. And just looking at the anticline for a minute, we would say that both of the sides of the anticline that are going down from the top of the arch, that's what we mean by the limbs of this fold. So in this case here, on both sides of the anticline, the limbs are going down at about the same angle into the ground. So we would say that's a symmetrical fold. If we held a mirror right here, we would kind of see the reflection of one side of the fold on the other side. However, sometimes we can get into a case where one side of the anticline is going down into the ground much more steeply than the other side. And because if we held a mirror here, we would see something very different than what we actually see in this drawing, we call that an asymmetrical fold. The symmetry on both sides is not the same because one limb is dipping down into the ground much more steeply than the limb on the other side of the anticline. And this can happen all the way until we get these originally horizontal beds of sedimentary rocks that are actually now vertical. And if we keep pushing things together, we keep making folds, we could actually get into a situation where we get the one limb of the fold dipping down into the ground at an angle greater than vertical. So it's kind of dipping back on itself into the ground here. And we would call that an overturned fold. Another thing to note about this example is we can kind of see in this example, the mountains kind of follow the top of the anticline. And that can happen, but one of the most important things about how these anticlines and synclines are expressed on the surface of the earth is where the most resistant layer of rocks are. And in this case, it looks like a sandstone, so that makes sense. The sandstone's not getting eroded away, so the top of the anticline could also be associated with the mountain ranges. However, we'll come back to that in a minute, but another way that we can get different fold geometries, if the top of the anticline as we follow it across space does not stay horizontal, but the top of the anticline actually plunges into the ground at an angle. So if this happens, we don't get these straight lines anymore. We kind of get this sinuous pattern where we kind of get these big things going in different directions here. And that's because the axes of the folds are no longer horizontal. They're now plunging down into the ground. And we can also see here that the mountains in this case are associated with this yellow layer of rocks, which I would guess is the most resistant to erosion. And we can see the type of patterns it forms. So here we have the yellow mountain here. We come over in this direction. Once it's plunged into the ground, we no longer see it. We come back in this direction. It plunges out of the ground here, and then we get the next one. So we can get these patterns, this very sinuous pattern of one ridge after another. Sometimes these ridges are all connected together, and we get these very kind of intricate looking mountain ranges. One good example of that is the Valley and Ridge province in Pennsylvania. And this is kind of in eastern to central Pennsylvania. And we just get these ridges. The ridges are shown kind of in this area here. They kind of go back and forth like that because that's exactly what's happening here. This is a plunging series of synclines and anticlines. Their axes are not horizontal, but they're dipping into the ground. And it gives this very unique pattern where we just kind of go back and forth and back and forth and back and forth as we trace these patterns along the ground of the ridges in the Valley and Ridge province of Pennsylvania.